Hi, today we're going to be looking at the relationship between pH and H+ concentrations in solution, the relationship between pOH and hydroxide concentration in solution, as well as the relationship between pH and pOH. The big thing we're going to focus on is just doing some really simple calculations. Now, if you look over here, we're going to first talk about pH and how it relates to H+ concentration in solution. Now, when I say H+, this is also the same thing as saying H3O+, okay, which is the same thing as hydronium. That's the term we use for it, H+ ion. Now, let's say that we have a concentration of hydronium of 0.0001 molar. And we're told we need to find what the pH is. Well, there's a really simple way to do this. A really, really simple way. Let me show you. Now, all you need is one simple formula, and that is this, that the negative log of the pH, okay, or in this case, the H+ concentration, is equal to pH. That's all we have to do. So let's just plug this in. Negative log of 0.0001. Okay, and again, the brackets represent concentration. Remember that, they represent molarity. All we got to do is solve this and work it out. So we hit negative log 0.0001. And look, you find that your pH is 4. So this is equal to pH, and our pH is equal to 4. Now, the other thing that we can look at right here is the relationship between pH and pOH. Now, that relationship is actually pretty simple. Okay? The more acidic something is, the lower the pH. Okay? The more basic something is, the higher the pH. Now, the pOH scale is reversed. So if we want to look at this, there's also a relationship between them. pH, I'll write it over here, plus pOH always will add up to 14. So if we know the pH of this solution is 4, we can very easily find the pOH. All we need to do is basically do a subtraction problem. So we find that the pOH is equal to 10 in this case. That was pretty simple, I think. And I hope it is for you too. However, there's another way we can go about this, and that is, what if we're not given the H+ concentration? What if instead, again, when talking about pH and pOH, okay, what if instead we're given a hydroxide concentration? What if we're given OH? Okay, let's say that we have a hydroxide concentration of 0.00047. Now, you'll also see these written in scientific notation a lot, okay? And to write this in scientific notation, we would write it as 4.7 times 10 to the negative 4th. Okay, that would be our concentration as well. And remember, both of these concentrations would be in molarity, which is what we always measure concentration in. So, to look at this and solve this basically, we're going to find, in this case, we want pH again. So let's say the problem is asking us, what is the pH of this solution? Now, first thing you got to do is use the exact same formula I just showed you to find the pH using hydronium. But this in case we have hydroxide. So we go negative log of our concentration. I'm going to write it in scientific notation here. All right. Now, this will not equal pH. The answer to this will not equal pH. Okay? I want you to understand that. Since we are dealing with hydroxide to begin with, that means our answer will deal with hydroxide. So, between pH and pOH, you notice, look, pOH has a hydroxide in it. That's obviously what we're going to be finding then. So, the answer will be pOH. So, to solve this, you just take the negative log of 4.7 times 10 to the negative 4th, and that gives you your pOH, which in this case is 3.3. We'll round it up to 3. So 3.33. Now, this is not the pH, but we want to find the pH. So remember, pH plus pOH is equal to 14. So if we have 3.33, then all we need to do is subtract that from 14. So 14 minus 3.33 gives us a pH of 10.67. Now, those are the really simple basic relationships of pH and pOH. You use H plus concentration, just like we did here, okay, the first example, to find the pH of something directly. You use the OH concentration, that is the hydroxide concentration, to find the pOH of something, which you can then use to find the pH of a solution. Okay, the next video that I'm going to show you on here will show you how to go from pH back to hydronium, H plus concentration, and also from pOH back to hydroxide concentration. So if you want to see that, look down below.